Alright, this lesson is on natural logarithms. Just like common logs are logarithms with a base of 10, natural logs are logarithms with a base of e. And e is just a constant, just like pi is a constant. It's an irrational number. It never ends, does not have a repeating pattern. The approximate value of e is 2.718. And as far as notation, log base e oftentimes is written, actually most of the time is written as ln. Alright, so those two notations are interchangeable. When you're simplifying natural logs expressions or solving natural log equations, in most cases what you want to do is rewrite the natural log as log base e, and then you would perform whatever methods is necessary to simplify or solve the equations. Now for this one, we have two natural logs set equal to each other. Since they both have the same base e, we can set what we're taking the log of equal to each other. Solve for r, we get r equals 8. Here we have a natural log, so we want to divide both sides by 7 to isolate the natural log. And then we want to put it in exponential form, so we want to rewrite the natural log as log base e. And then put it in exponential form by writing e to the 1 power equals n minus 6. And to isolate the n, we would just add 6 to both sides, so n would equal e plus 6. In this example, again, we have two logs set equal to each other, so we can now set what we're taking the log of equal to each other. And we get a quadratic equation. It's a difference of two squares. So we'll have n and n, 3 and 3, 1 plus, 1 minus. So we get n equals plus and minus 3. In this example, we want to condense those two logarithms into one logarithm. So whenever you subtract two logs with the same base and you condense them into one logarithm, that's the same thing as dividing the first by the second. So to condense those two logarithms, we would have the natural log of x over 5 equals 3. Now we want to rewrite the natural log as log base e. And then we can put it in exponential form by writing e to the 3rd power equals x over 5. And then to solve for x, we just lastly multiply both sides by 5. And we get x equals 5e to the 3rd power, which is approximately 100.4277 to the 10,000th place. Alright, again, we want to condense the two logarithms on the left side of the equation. Since they're being subtracted, that's the same thing as when we condense them to divide what we're taking the logarithm of. And then rewrite the natural log as log base e. Put it in exponential form by writing e squared equals x minus 10 over 2. And to isolate the x, we need to multiply both sides by 2. And then add 10 to both sides. So x equals 2e squared plus 10. And in this last example, we want to again condense the two logarithms by rewriting them as the natural log of 4 over 6 minus 5x. Rewrite it as log base e. Put it in exponential form by writing e to the 4th equals 4 over 6 minus 5x. Flip-flop the e to the 4th and the 6 minus 5x. And then subtract 6 from both sides. Divide both sides by -5. And just clean everything up. Get a common denominator. And we get x equals 4 minus 6e to the fourth over e to the fourth, and all that's going to be multiplied by negative 1/5, giving us 6e to the fourth minus 4 over 5e to the fourth.